Hello guys, how are you all doing? Welcome back to my YouTube channel. And in today's video, we are going to study the chapter Atomic Structure. But this chapter is very large, so I have divided this chapter into many parts. So this is part 1, and the topics covered in the part 1 is Dalton's atomic theory, subatomic particles, discovery of electrons, protons, neutrons, nucleus, Rutherford's atomic model, and Bohr's atomic model. So without any delay, let's start. So, atoms. What is atoms? Atoms are the buildings of rock of matter and cannot be chemically subdivided by any ordinary method. So, this is a very simple definition. Let's go to the next slide. Dalton's atomic theory. So, there were many views given about the atom before Dalton only, like Maharshi's Kannada view on atom and Democritus' model of an atom. They both also gave that all about Paramanu and Anu, that all matter is made up of atom, but they were just expedition. That means that they were not proved experimentally. They just said it. They didn't have any proof to prove it that it is true. But in 1808, Dalton's atomic theory, with his experiments, he thought about atom. And the postulates of Dalton's atomic theory are: all matter consists of tiny particles called atoms. Atoms are indivisible or indestructible. In chemical reactions, atoms are rearranged, combined, or separated. Atoms of one element are different from the other elements. Atoms of one element can combine with the atoms of other element. So this is the postulate of Dalton atomic theory, and it is compulsory for us to by heart. So he showed it experimentally. He didn't just give a view on it. Next, so let's go to the next topic, that is subatomic particles. Yes, though Dalton, in this slide we see that Dalton chemically proved that what atoms matter is made up of atoms, but left to an unanswered question: what are atoms made up of? So that question was answered. So that led to the discovery of subatomic particles. This was the first discovery was by Sir J.J. Thomson. He discovered electron, and his discovery of an electron was the first step towards the detailed model of an atom. In 1897, an English chemist, Sir J.J. Thomson, proved that an atom can be split into even more parts, and his discovery of the electron was the first step towards the detailed model of an atom. So he was the first one to discover electrons. So with that electron, it got deeper and deeper, and all the subatomic particles of an atom was found out. Next. So discovery of electrons. So before J.J. Thomson, Sir William Crookes also played a role in discovering electrons. In 1879, Sir William Crookes conducted an experiment. So he took a discharge tube. So here I'm showing you with the laser point. Here he took a discharge tube, and in the discharge tube there were two tubes. In the discharge tube, one tube was connected to the negative terminal and another was connected to the positive terminal. The negative terminal was called as cathode. Here I'm showing you, this was connected to the negative terminal, so it's called as cathode, and this was connected to the positive terminal, so it is called as anode. So basically we know that gas is not good conductors of electricity. It's not a good conductor only, but under two postulates they become good conductors, that is high voltage and low gas pressure. Under these two conditions they became good conductors. So when there was air at a very low pressure and they gave an high voltage, Sir William Crookes observed that there was a green glow being emitted from the cathode rays. So the cathode tube emitted some rays. These rays were called as the cathode rays. They were somewhat greenish in color. He named it as cathode rays because they were emitted from the cathode. And he also found out that these were negatively charged particles, because when he kept a positive terminal, he saw that the rays got attracted towards the positive. That means that this is a negative rays. So this led to the discovery of cathode rays. Next, properties of electrons. So what exactly Sir William Cook did this? He just did this experiment and he gave it as cathode rays. Then J.J. Thomson came and he named it as electrons. He after naming it as electrons, he was the one who discovered that it was negatively charged particles, and he calculated their size, mass, everything. So Sir William Crookes, just what he did is he just made sure that he just told that cathode produced some rays called as cathode rays. It was J.J. Thomson who named it as electrons, who checked their charge, who measured their weight and their charge. Next, properties of electrons. Electrons are negatively charged particles. The ratio to the mass ratio is equal to all electrons. So there are many atoms. In this case, the mass to the ratio, the charge to the mass ratio. So in order to get to know the size of electrons, J.J. Thomson took the ratio of charge and mass. He took the ratio and he saw that the charge of the mass ratio is equal for all electrons. The mass of the electron is 1 by 2000 times lesser than the mass of proton and neutron. Therefore, the electrons do not contribute to the mass of an atom. And it is said that here it is given 1 by 2000 times lesser than the mass of proton and neutron. So proton is mass is equal to hydrogen. That means that the mass of the electron is 1 by 2000 times lesser than the mass of hydrogen. And we know hydrogen is the lightest gas. So then if we see it is 1 by 2000 times hydrogen, the hydrogen only, then we can understand the mass of the electron is completely negligible. So the next property is electron has an electric charge 1.602 into 10 to the power minus 19 coulomb. So next, let's go to the next topic, discovery of protons. The protons were discovered by an scientist named Goldstein. So he discovered the protons. So he took the same discharge, he made all the same setups given by Sir William Crookes. And what he did is, he did the same. He gave low pressure, high voltage and all the necessary things. And what he did, there's only one change that he did is, he put a perforated cathode. So perforated cathode is nothing but cathode with holes, just holes in that tube. So what he observed is, yes, even cathode produced cathode rays, but through these holes he also saw a red glow. And this red glow was being emitted by the anode terminal. So the red glow was being emitted by the anode terminal. It was seen at the end of the perforated cathode, and he named them as anode rays or canal rays. And he said that these were being produced by the anode. They're positively charged when he observed the deflections from the magnet, and he named them as protons. So this was the discovery of protons. Next, properties of protons. Protons are positively charged particles. The charge to the mass ratio is not fixed. So in electrons we saw, so here in the electrons the charge to the mass ratio is equal for all electrons. But when it comes to the part of protons, the charge of the mass ratio is not fixed. It may vary from proton of one atom to proton of another atom. And the mass of the proton is 1.672 into 10 to the power minus 24. This is equal to hydrogen. So mass of the proton, yes, it is less, but it still has a role in atomic mass. Then is the charge of the proton is 1.602 into 10 to the power minus 19 coulomb. That is equal to the electron, but the only difference is that is negative, this is positive. So this was electrons and protons, but still after this, there was still one unanswered question. How were the electrons and protons arranged in an atom? This was also a very tough question. Next, then in 1904, Thomson's model of an atom came, that is the plum-pudding model. So in this model, atom was surrounded with protons and the electrons embedded in. So basically, in this atom, it is a sphere of fully positively charged particles. So here you can see positive, 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 and the sphere is positively charged particles, and you see here some minus signs, that is negative. So the negative signs are embedded inside the positive. So he said this is the plummeting model in which positive, there is a sphere of positive and the electrons are present inside, and he proposed this model in 1904. But then you see that Thomson's model failed to answer many questions, so it was not answered. Many theoretical questions were not being answered with a plummeting model, so Thomson's model was not accepted. So this was not being accepted, and then comes the discovery of nucleus. So from here came next is it's a very, very, very important topic. So we need to be understanding this very, very, very clearly. So discovery of nucleus, after the discovery of nucleus only came the correct atomic model, and this important work, discovery of nucleus and the correct atomic model, was by a very honorable scientist, Ernest Rutherford. So he was the man who discovered nucleus and gave the correct atomic model, which even we follow today with a little modification, that's it. So he was the main person for giving, he was the main reason for the discovery of subatomic particles. In 1911, Ernest Rutherford carried out his famous gold foil experiment. So in the next slide, we'll see about gold foil experiment. This led to the discovery of nucleus and was the correct model of an atom, and the materials required in this was 0.0004 centimeter sheet of gold foil and fast moving alpha particles. So a very thin sheet of gold foil and fast moving alpha particles. So let's understand this very properly from starting, because this is very, very, very important. In 1911, Ernest Rutherford carried his gold foil experiment. This led to the discovery of nucleus and was the correct model of an atom. In this experiment, there was a 0.0004 centimeter sheet of gold foil and was even fast moving alpha parts were taken. Next comes the gold foil experiment. This is the most important topic, so we need to be concentrating here. So let's start. When the alpha particles were emitted, most of the particles pass through it. So here is let's understand it diagrammatically. Here's the alpha particle emitter, any alpha particle emitter. Here's the gold foil, and here there was a sheet kept to watch upon the deflections. How does the alpha particles move? Now, first, what happened is, first observation was, most of the alpha particles easily passed through the gold foil. So the alpha particles being emitted, almost all were being able to pass through the gold foil easily. A very few got deflected at a large angle, and a very few got deflected at a small angle. So when the alpha particle was emitted, almost all of the particles were able to pass through the gold foil. So some alpha particles got deflected at a larger angle and some got deflected at a smaller angle, and very, very, very few, like some 1 in 1200 particles bounce back to the alpha particles emitter. So very few, like 1 in 1200 particles will bounce back to the alpha particles emitter. So it came only very, very, very few bounce back to the alpha particle emitter. So I'll tell you this again. Observations when the alpha particle was released is, most of the particles easily passed through the gold foil, almost all. Some got deflected at a larger angle and some at a smaller angle. And very few, like 1 in 1200 particles, bounce back to the alpha particle emitter. Now let's see the most important part. Conclusion of gold foil experiment. So there is a center particle called nucleus, which is small and is so responsible for deflection, passing through and bouncing back of the particles. So let's read this sentence once again. There is a center particle called nucleus, which is small and so responsible for deflection, passing through and bouncing back of particles. So here you see, let's see here. So think that there is a very small particle inside it. Just think, don't think nucleus and all. There is a very small particle inside the 0.0046 centimeter thing. There's a very small particle present. So the sides and all, there is a lot of space, very, very small present exactly in the center. So when there's a very small present, then you know easily all particles can flow because it is presented exactly at the center and the size is very, very small. Then of course easily almost all the alpha particles will pass through. What will happen? Some will hit at the side of that particle and get deflected at a large angle. Some will hit at the other side of the particle and get deflected. So that alpha particles which get deflected at large and small angle, they won't hit the middle part fully. They hit a small part because it is very small and present exactly at the middle. Only a very, very, very few particles, it will come and hit exactly the center of the center particle, that is nucleus. They will exactly hit the center and they will bounce back. So in the next slide, we see there's the center particle of nucleus, which is small and is so responsible for deflection, passing through and bouncing back of particles. So here, small particles, so most of the particles will pass easily. Some particles get hit at the small part of that nucleus, so they get deflected, and very few hit the nucleus and they bounce back. So when he saw this, he concluded, he named them as nucleus. And Rutherford's atomic model, after he discovered nucleus, he gave the correct atomic model. There were little changes after it, but the main concept is always even studied now. Most of the atomic mass is concentrated on nucleus. It has a positive charge as it contains protons. Most of the atomic mass is concentrated on nucleus and it has positive charge. And it's very important to understand that protons are present inside the nucleus. So protons are present inside the nucleus and it has a positive charge. An atom is electrically neutral. We know that atom is electrically neutral. That means that the number of protons is equal to the number of electrons. So this we even studied today. Number of protons equal to number of electrons. Nucleus is a positive charge because it contains protons. So this was the important discovery of Rutherford, the great scientist who gave a Nobel contribution to subatomic particles discovery. So this was the Goldfall experiment and this is 100% super duper important. So hope you all understood the concept. Going ahead, Bohr's atomic model. Yes. Now Bohr, I'll tell you this in extra information that Bohr was a student of Rutherford. So Bohr was nothing. He was a student of Rutherford. So he knew exactly what all Rutherford had done. So Rutherford all did atom. He discovered nucleus. He gave atomic model. But one very small question was unanswered that Rutherford's atomic model did not explain the stability of an atom. It did not explain the stability of an atom. That means, so what is stability? In this sentence, we'll read it. Positive and negatively charged particles would attract and electrons would release energy and the atom will fall. But this did not happen. So normally when an atom is there, for example, so normally this atom is there. So electron is there, proton is there, and neutron is there. Wait, neutron is not studied, so let's our neutron. This is the nucleus, and nucleus proton is present, and the electron is there here. So proton is there inside this, and proton is positively charged, and electron is negatively charged. So when protons positive and negative gets attracted, we know this. So when they get attracted, they would release energy to go and attract it. And when they release energy, there will be no energy in it, and that would result in collapse of the whole atom. I'll explain you this again. Proton is present, electron is present. Both gets attracted as negative and positive. So when they both get attracted, the electrons would release energy and there will be no energy in the electrons. And when there's no energy in the electrons, what will happen? the electrons will collapse. But this did not happen. This is explained by Bohr, the student of Rutherford. He said in 1913, Niels Bohr proposed a modified version of Rutherford's atomic model, the circular shells in which electrons revolve. So in this diagram, you do see circular shells are there, and here are the electrons revolving. And this, where they are revolving, see, I'm pointing here. There are shells on which electrons are revolving. This electron is there now. So this electron is revolving on the shells. So what happens is, when these electrons are revolving around the shell, this cells has particular energy level. So in this energy level only this all happens. So because of this energy level, electrons are being stable. So this is why the atom does not collapse. So this was given by Niels Bohr in 1913. And he said that the shells are named as K, L, M, and so on. So this will be, so this helps in electronic configuration, which we'll learn in the next part. So discovery of neutron. So proton is done, neutron is done, and nucleus is done, and the correct atomic model is also given. Now, discovery of neutrons. So they, at that time, they didn't have any idea of being neutron only. They didn't know any particle until one time when a scientist, what he did is, James Chadwick, he compared the mass of the weight. So first of all, let's understand this thing. The mass of the electrons is negligible. We know that it is 1 by 2000 times of hydrogen. So the mass is completely negligible in electrons. They don't, but actually they almost don't have mass only. It's so lightweight. So the mass of the electrons is not calculated. So the mass of the electrons does not play any role in atomic mass. So you don't calculate the mass of electrons. That means that the atomic mass depends on the mass of protons and nucleus. Yeah, nucleus. So, but when the mass of the atom and the mass of the proton and nucleus was compared, then the mass of the atom was far more than nucleus. So let's understand this thing here properly, because this might be a little important. Yes. So see here. First of all, we know that electron's mass is the negligible. It is completely negligible. That means that the atomic mass depends on mass of protons and nucleus. So proton plus nucleus. So that is protons plus nucleus should be equal to atomic mass. Atomic mass is nothing but the mass of the atom. So here the mass, that is the protons plus nucleus is equal to atomic mass. That should be equal, because the mass of the electrons is completely negligible. But James Chadwick, when he compared the mass of the atom, and he added protons and nucleus mass, and he got a certain result, and he compared it with the atomic mass, and he saw that the mass of the atom was very much more than the protons and nucleus. So this question led to the discovery of nucleus. So James Chadwick was the scientist who discovered this in 1932. So he discovered neutrons, saying that this, and one property of neutron, that it has no charge. So in this diagram, in any atom diagram, we'll be able to see that atoms will have no, the nucleus will have positive charge, but nucleus will contain protons and neutrons. Then protons charge is positive, but neutrons has no charge only, so it does not play any role in the so it does not play any role in the charge of the nucleus. And protons plus neutrons form nucleus, and it is also called as nucleons. So protons and neutrons are present inside nucleus, and this is also called as nucleons. So guys, this was the easy topic, atomic structure, and this video part 1 was all about the history of the subatomic particles, how they were discovered. Please do revise all this, and especially gold foil experiment, because they are super duper important. Hope you enjoyed and understood the video. Thank you. Bye bye.